right, y'all. So here we are starting a brand new unit. We're going to be talking about stability of atoms and bonding. So this is the part where I will tell you it is going to get hard. So we need to really be focusing and making sure we understand, and we'll be reviewing these concepts literally on a daily basis. You're going to get so sick of it. So let's talk about combining elements at first. So most elements are not found by themselves in nature. They are actually and usually found combined with other elements. So a compound, which we've kind of already talked about before when we talked about matter, are two or more elements chemically combined. That is very important to remember. The properties of a compound are very different from the properties of the elements that make up the compound. So for example, sodium and chlorine are very, very, very different from sodium chloride, which is what table salt is. So let's talk about chemical formulas. So chemical formulas are used to tell what elements and how many of each of those elements are in a unit of a compound. So for example, H2O is water. It contains 2 atoms of hydrogen and 1 atom of oxygen, and it looks like this. Then you have ammonia, which is NH3. It contains 1 atom of nitrogen and 3 atoms of hydrogen, and it looks like this. Now let's talk about forming those compounds. So why do elements form compounds, first of all? To be stable. That is their life goal. All elements want to be stable. They want to be fulfilled. They want all of their electrons to be taken care of. So that's why the octet rule is a thing. Atoms will gain, lose, or share electrons in order to have 8 electrons in their outer energy shell. Their end game is 8 because that makes them happy. So this is called stability. That means they have a full and complete outer energy level of valence electrons. That's why I kind of introduced valence electrons earlier in the previous unit, because it has to do with having that fulfilled and be stable when we get into bonding. 8 is for every element except for hydrogen and helium. That is very, very, very important to remember. Hydrogen is atomic number 1 and helium is atomic number 2. Hydrogen doesn't have room to fit 8 valence electrons. Helium doesn't either. It's fine with having 2. So those are the 2 exceptions to our octet rule. So let's talk about forming compounds. So let's go back to our example about sodium chloride, which is table salt. So you have a sodium atom and a chlorine atom. Sodium has 1 valence electron because it is in group 1. So there's its valence electron in green. If it loses that 1 electron, its outermost energy level will be full and will be stable. So if you look at this middle ring right here, it has 8. It's happy. It's good because it's lost that valence electron. Chlorine, however, has 7 valence electrons in its outer ring, as shown here in green. If it gains 1 electron, its outermost energy level will be full and it will be stable, and that's how it likes to be. So this is what happens. This sodium atom provides that 1 extra atom, so chlorine can be stable and making sodium stable. This is how bonds happen and form, in this example, sodium chloride or table salt. All right, so would elements ever not benefit from forming compounds? Yes, if they are already stable, which we've kind of discussed this, and those are our noble gases, group 18. This is why noble gases are non-reactive. They're happy. They like to be by themselves. They are the kings of their castles, queens of their castles. They don't need no man. They don't need no woman, okay? They are okay with being by themselves. Their outermost energy levels are already full. They don't need help with that. So examples would be helium, which we kind of discussed a little bit previously. It has 2, it's fulfilled, it's good. Neon, argon, any of those group 18 elements would be included in these noble gases. So let's talk about bonds specifically. When atoms gain, lose, or share electrons in order to become stable, they form chemical bonds. Chemical bonds are a force that actually holds atoms together in a substance. There are many types of bonds that can form, and not all bonds are created equal. We're going to only learn about 2 of them in 8th grade. If you take chemistry in high school, you'll learn about a few more because there's quite a bit. So we're going to learn about ionic bonds first. Ionic bonds are when atoms transfer electrons in order to be stable. So that means an atom could gain or lose an electron depending on where they are in the periodic table. It's usually between a metal and a non-metal. This is very, very, very important to remember. Between a metal and a non-metal, and they transfer electrons. This results in the formation of ions. So let's dive into ionic bonds here. Ions are atoms or molecules that have a charge due to having lost or gained electrons. Cations are positively charged ions. Atoms that have, or molecules that have lost electrons are considered cations. So they've lost, so they're positively charged. The easiest way to remember this is if electrons are negative. So if you lose one, you become more positive. They are usually metals. So on the left side of the periodic table. So an example would be magnesium. Magnesium is a metal. When it becomes an ion, it becomes positively charged, making it a cation. So it loses those 2 green electrons there because those are its valence electrons in order to become more stable. So when we're creating the cation of magnesium, it gets a +2 charge. And if you notice, this charge sits as a superscript on the right-hand side of the element symbol. It's very important to remember. Now we have anions. So anions are negatively charged ions because the atoms or molecules have gained electrons. Remember, electrons are negative. So when you give something more of a negative thing, it becomes negatively charged. These are usually your nonmetals, which are on the right-hand side of the periodic table. So an example of this is oxygen. Oxygen has 6 valence electrons, which you can see here in green. So it needs 2 electrons it needs to gain 2 electrons in order to be stable. So when we create an anion with a charge for oxygen, oxygen has a -2 charge because it needs 2 electrons. So let's go ahead and go through some examples. So number 1, what ion will lithium form? First of all, we need to look at our valence electrons, which are here in green. So lithium has 1 valence electron. That means it will lose that 1 electron in order to be stable, creating a cation with a +1 charge, making it lithium +1. Lithium is a non-metal, so it definitely is a cation. Let's talk about nitrogen next. So nitrogen has, 5 valence electrons seen here in green. So it will gain 3 electrons in order to be stable. So creating an anion with a -3 charge, so nitrogen -3. So this makes it an anion again. And we'll go over this tomorrow in class, so don't freak out. I promise we'll get practice. So elements in the same group have the same number of valence electrons, which is so nice. So nice. Okay? Same thing applies to ions. Elements in the same group will form those exact same ions the exact same way. So for example, group 1 has 1 valence electron. That means they're a +1. Okay? Group 2, they have 2 valence electrons, so they're +2. And so on and so forth. We will not talk about transition metals, at least not most of you. Transition metals are a little funky, and we won't bother with those because they are scary. So some examples of these are like elements in group 1, like I said, have valence electrons. Some will lose 1 electron to become more stable. Therefore, if I'm forming an ion with +1 charge, that's lithium. Sodium is a +1 charge, and potassium is also a +1 charge. Literally different atoms, but they are all in the same group. This charge is actually called its oxidation number, okay? Oxidation numbers is the last thing we'll talk about with this particular section, but oxidation numbers are the charge of an ion within a compound. So that's the anion or the cation. It's written as a superscript to the right of the symbol. That is very, very, very important to remember. So for group 1 elements have 1 valence electron. This means they have a +1 charge. Group 2 elements have 2 valence electrons, which means they have a +2 charge. We're going to skip groups 3 through 12, which are our transition metals. Group 13 elements have 3 valence electrons, meaning they have a +3 charge. Group 14 elements have 4 valence electrons, and they can be either positive or negative because group 14 is our group that contains things like metalloids. So they can behave either way. They can behave like a metal or a non-metal, so it kind of depends on what they're being bonded with. Group 15 elements have 5 valence electrons, so they have a -3 charge. Group 16 elements have 6 valence electrons, so they have a -2 charge. And group 17 elements have 7 valence electrons with a -1 charge. So if you have any questions, let me know. We're going to review.